All right, welcome back. We're going to go on to the next topic, which is calorimetry. Okay, and if you think about that word, anytime you see the metry, the metry suffix, that just means the measure of. And so calorimetry is literally just translating to the measure of calories or the measure of energy content. Okay, we do this a lot. We do this for food, we do this for reactions. All of those caloric values on your nutritional labels you can get from calorimetry, from literally measuring the calorie content of the food. Okay, so we're going to talk about the process of that and kind of the theory behind why this works. But first, I just need to make sure you guys remember the different signs, like positive or negative, what they mean when we're talking about heat going in and out of system and surroundings. Okay, so remember we have our system. Here I'm just going to make it a little square. Heat can either come out of the system or go into the system. Now, if heat is going out of the system, hopefully you guys remember, that would be a negative Q. That would be a negative delta T, okay? And therefore a negative overall change in energy. Energy is leaving the system. The temperature of that system is decreasing. That is exothermic. Okay. Now the other one is endothermic, where energy or heat is going into the system. So that would just be a positive Q, a positive change in temperature, and a positive change in overall energy. And we call that endothermic. Okay. So hopefully you remember that and don't forget that, because it's very crucial for calorimetry. Now, when we're talking about the system and surroundings, it's imperative that you remember kind of our definitions, right? So the system is just whatever you're focusing on in the universe. It can be anything. It can be you, it can be me, it can be this whiteboard, it can be this marker. Whatever you are focusing your attention on is called the system. Everything else in the universe is called the surroundings, okay? So if a system increases its energy, if it absorbs energy, it must be getting that energy from where? Good, the surroundings, okay? So if a system has an overall positive Q value, like it's absorbing heat, well then in terms of our surroundings, that would have a negative Q, because all of the energy that the system acquired had to come from the surroundings. So the surroundings are going to lose energy while the system gains energy. Okay, and vice versa. If the system loses energy, it must go to the surroundings, so the surroundings will gain that energy. They will always have opposite signs for delta E, delta T, and Q. Okay? Now, it's that fact that kind of is the groundwork for our calorimetry equation. So, in order to be able to measure the energy content of a system, you have to think about the system and the surroundings. So, the Q of the system is now going to be equal to the Q of the surroundings, because all of the heat that a system acquires must have come from the surroundings, so they have to be equal, but opposite signs. Okay? So we're just going to add a negative sign right here to the Q of the surroundings just to keep them opposite signs as each other. Okay? So it doesn't really matter even if the system is losing heat, this would be negative, and then it would make that Q for the surroundings positive. So they will still be opposite signs no matter what. Now, as of right now, if we put Q of the system equals negative Q of the surroundings, we have a way to calculate the Q, right? We've been using the Q equation as M times C times delta T. Okay, but if we're going to apply it to calorimetry, where we have a Q of a system and the Q of the surroundings, we have to be a little more specific than that. Here on the left side, it would be the mass of the system times the specific heat capacity of the system times the temperature change of the system. And that's going to be equal to the negative M times C times delta T of the surroundings. So the negative, and then here the mass of the surroundings times the specific heat of the surrounding times the delta T of the surroundings. Okay, you have to be very specific when using all of these variables because there's a lot of them. So keep track of all of them.